From University of Maryland University College, this is Thursday Thoughts with Dr. Alan Drimmer. This series features faculty and friends of UMUC highlighting areas of academic expertise.
Welcome to Thursday Thoughts at University of Maryland University College. I'm Alan Drimmer, the Chief Academic Officer, and today I'm joined by Dr. Barry Douglas, Program Chair in Systems Engineering, and we're going to talk about systems engineering at the university and in our society more generally. But thank you for being with us and talking about your field.
Thank you for joining me to speak of this subject, which to me is a terrific topic, obviously.
Yeah, I've been learning more about it. I can't say that it's something we talk around the kitchen table about, but I've learned about it, and I'm really interested in the program and really about the field more broadly in our society. First, what is systems engineering?
Well, systems engineering has been around as long as engineering has been around as a profession, which is to say that engineering machines, man-made machines, are all complicated devices that can be regarded as a system of components. So systems engineering studies how all those pieces work together, how they're turned into something useful, and just generally the study of systems is not about the individual parts, it's how the whole thing works together. So that's what systems engineering is. It deals primarily with really complex systems. So in other words, it's not really important to study something relatively simple that one person can have in their mind. But as soon as you start looking at something so complicated that one person can't grasp the whole, you have to have formalized methods for understanding what's going on to make sure everybody's talking to each other using the same language. They're not missing anything. Everybody understands their job and what they're supposed to do to bring the whole thing together. So that's what systems engineering is.
So does that mean that a systems engineer needs to understand all of the different components?
No, not really. In fact, that's probably impossible. I mean, a complex system is going to have, for example, an airplane, just an ordinary commercial airliner, has electronic components, it has a fuel system, it's got all the control systems that only control engineers understand. It's got the aerodynamics and et cetera, and nobody can really understand that properly. No one person could ever design an airplane as complex as a modern airplane. As a result, you have to have someone that can lead the team without knowing all the details of every component, but can understand the issues involved in developing the whole system. And making sure everybody's doing their job, as I say, and putting it all together so that it flies without somebody going, whoops, I thought you were using the metric system. In fact, you're using the English system, which is exactly what has happened in a famous case of NASA sending an orbiter to Mars, and the darn thing was supposed to go into orbit, and it flew in just a little bit too low and skimmed the atmosphere and crashed into the planet because the contractor was using the English system of units, inches and feet, and NASA was telling them to do it in metric or vice versa. I don't exactly remember the details, but the point is they weren't talking to each other using the right language, and it cost hundreds of millions of dollars to the United States because of some silly little mistake.
So it could be that even if all the different pieces work well on their own together, there needs to be a special kind of process and attention to make sure that they all work well together.
Yes, correct. And it is not just a matter of somebody being in charge and knowing what they're doing. There's actually methods that have been developed to address that issue because the systems can be so complex that it doesn't matter if you're smart and you're on top of things. You're not going to be able to handle it unless you've got some techniques behind you, some formal methods to make sure that the right techniques are followed and to get to the final result.
That's really incredible. I never knew such a thing existed. I mean, our whole world is full of these complex machines and processes, and I never really thought about it. I mean, is that a common reaction? I mean, you drive in a car, like you mentioned a plane. Same with a car. What is a car? There's mechanical parts, there's electronics, there's ergonomics, there's all these different things, but I never really thought about all of them working together.
Well, yeah, and actually systems engineering was not a formal discipline by itself until about the 1950s. Some people, this was probably an outgrowth of World War II, where engineers had been exposed to the way the military kind of organizes everything into giant projects, the Manhattan Project and others.
Right.
And they began to realize that they needed to do that with some systems that were being developed for the military, particularly in the aerospace industry, rockets and so forth. They were crashing a lot. And so that was one of the major forces pushing them into thinking that way. As they began to do it, others began to, well, first of all, realize that they already had been doing some of those things, just not calling it systems engineering. And then they began to develop this formal discipline. So it is today still a growing field because not everybody that does systems engineering is trained as a systems engineer. They just do it. And not everybody recognizes it as a specific discipline of engineering, though it's becoming quite well known.
And what about in the engineering community? Do other engineers recognize it as a separate discipline?
Oh yes, systems engineering is understood within engineering. Again, though not everybody is trained as a systems engineering.
Sure.
Not everybody that does systems engineering even knows there are college degrees in it. But a lot of people do systems engineering. They're aware of it. It's part of their job. They understand the various things that go into it. For example, writing specifications that everybody can understand, and you can send to another company, and they'll know how to work through them and develop a product from your specifications. That kind of thing every engineer knows. They just don't necessarily know that has its roots in systems engineering.
So how do most people come to this field? Do they come from other parts of engineering or other sciences, or where do most students come from that are interested in this?
It would be people that are already working typically in a technical field, and they're getting to that point in their job where they see, first of all, that their employer may be asking for a systems engineering expertise at the next level up. Yeah. Or even if they're not, that they know they want to move into a leadership position, and they begin to understand that systems engineering is how they can get to that point. Because if you're going to be running the show, you're going to be the guy in charge that has to manage the work of other engineers and other technical people. It doesn't necessarily have to be strictly an engineering enterprise. You have to understand that interplay between various technical disciplines and how to get them to work together. It can be people that have backgrounds in just IT. It could be networking people. It could be even somebody in the healthcare industry that works with technology in the health, which is, of course, is a big thing in the healthcare industry. So there's all kinds of possible applications, not necessarily strictly engineering. In fact, it is kind of a different field of engineering because it is not, even though it is typically taught at the graduate level, not everyone that goes into it is trained as an engineer at the bachelor's degree. In fact, it isn't necessary. Most of what we teach does not involve heavy math or physics. We're talking about introducing into our program some math, but not the kind of math that your usual engineer studies throughout his undergraduate years.
But still, there are techniques, there are frameworks and models that you were talking about earlier that it's a discipline. It's not just, hey, let's just talk about process improvement. There are tools.
Yes, absolutely. In fact, we're going to be introducing a new course called Model-Based Software Engineering in the fall, which involves software that is designed to help systems engineers model things in a formal manner. So that's a technical tool that we will be teaching our students, and it's becoming very popular in the industry.
Right. So is it common to have systems engineering at an undergraduate level, or is it mostly a graduate discipline?
It is almost exclusively a graduate discipline. I have seen a couple of schools offering bachelor's degrees. I haven't looked in detail at what they teach, but my guess is they're kind of teaching a general engineering degree, and then at the end they throw in the systems engineering focus to kind of focus it on something.
Right.
And there are some schools that just have general engineering degrees, but it normally doesn't make sense for somebody to be just a systems engineer without some other background, because it is not something you go into at an entry-level job.
Right. And it's interdisciplinary, so you have to have kind of broad knowledge and some experience, probably.
You certainly have to have broad knowledge. Experience helps. In fact, if you get a systems engineering graduate degree and you have no experience, you're probably going to be able to use it, but you won't get full benefit of it until your employer is ready to move you up into a leadership position.
Now, there was a concept that I heard about years ago, operations research, and this sounds a little bit like that. Is there any relationship between kind of that field and this? I don't know if you're familiar with that.
I am familiar with it. Operations research is essentially mathematical techniques applied to business, but in fact the same concepts can be used in systems engineering as well. And that's one of the techniques I was talking about, some mathematical techniques that are taught in systems engineering. For example, operations research, they teach how to optimize things. You have a process, you want to make sure you get the best out of it.
Right.
So operations research would teach you techniques, mathematical techniques for doing that, and systems engineers ought to know that if they can.
Right.
So we try, there's only so much we can teach our students in 36 credits, but we do our best to cover that kind of ground. And fortunately today, you don't really have to know how to slug through a bunch of numbers because it's all computerized and you usually have packages. In fact, some of the more famous techniques in operations research are available on an Excel spreadsheet. So, we can do it easily with our students.
Right. So as the field has grown, is there any relationship to the military, for example, which has a very, a large body of processes and using equipment and so on? Has the military had any sort of special role with systems engineering?
Yeah, actually, they are the ones that pushed it at the beginning. NASA and the DoD are two very strong proponents of systems engineering. The DoD has put out a manual on systems engineering, at least I should say the Air Force. And I'm not sure whether the Navy, but perhaps they have their own. So yes, the DoD is very strong on systems engineering, as well as I say NASA has been a big proponent of it. It's moving, of course, from the government into the contracting industry, the people, defense contractors, but now it's being seen outside of that arena more and more.
Right.
It's probably still making its way into general industry. There are some related fields. For example, industrial engineering is essentially, you could almost say systems engineering applied to manufacturing is industrial engineering. So that's a kind of an offshoot and it's been around longer than systems engineering as a formal discipline. So those techniques are not all brand new to systems engineering, but certainly the government has been a big proponent of pushing systems engineering, and we're seeing it pop up all over the place.
Right. But all that sounds, pardon my French here, but it sounds kind of nerdy. But as I look at the field, and it is new to me, there's also so much creativity that's part of it. It's basically problem solving, applied to these complex systems, isn't it? I mean, it's very much of a problem solving enterprise, it seems like.
Oh, it is. Well, to me, my love of engineering comes from the fact that I think it is creative. It's not creative the way an artist is creative, but it is creative. You're always coming up with new clever ways of doing things that nobody else knows how to do. And so that's engineering. And so systems engineering is the application of that mentality, that approach to complicated systems. So it is a little bit abstract in the sense you're not worried about the car driving down the road. You're worrying about the whole darn road system and how to avoid a roadblock or backups where there doesn't seem to be an accident causing it. You see that all the time around here.
Right.
You have all our highways seem to back up all the time, and nobody. You get to the spot where you think there's probably an accident, and there's nothing there, and that has to do with the way thousands of cars interact with each other. That isn't always a stable thing.
It does seem to me that as our world gets more complex with more and more systems, things can happen even if the different components are engineered perfectly together. It might not work the way that you want, and you see it all the time. Whether it's a car that shuts down because of some sort of automatic switch, or websites that turn off because of different things that totally inadvertent. Everybody worked on them, with the best of intentions and having it work properly, but together, sometimes these things happen. It just seems like this is a more urgent problem, and is going to continue to be.
Absolutely, and I think this is a problem that's only, in a sense, getting started, because we are going to become more and more complex in our interaction with technology. That's unavoidable. And the more we do so, the more we're going to see these kinds of things happening on a regular basis. Part of the solution isn't so much to avoid having those things occur, is to have a good plan of action when it does occur.
I see.
So, for example, in our power system, we have had enormous power outages in the past, tremendous blackouts that covered the entire Northeast and so forth, for what seemed like relatively small, triggers, like a lightning bolt hitting a switch or something in Canada. And yes, we suffered tremendous consequences due to that. And the solution is to go back and say, well, how can we redesign our system so that it behaves more intelligently? And yes, we can still have that switch being hit by a lightning bolt, and the switch can fail, but it's not going to take out the entire northeastern corridor. And that's the question that people need to ask, and the problem they need to solve. It's the same with the internet. I don't really want to step on the toes of our cybersecurity people, but they're concerned with how to prevent hacking. Part of the solution to the problem, though, would be to make our systems more robust so that even though they get hacked, it doesn't take down the entire country or whatever it is that foreign bad actors are trying to do.
Right. Yeah, it seems like it would apply to almost every field in different ways. The internet, it seems, is configured so there are pathways of traffic or things happen in one place. It's by definition a system, but it's very interesting because the system problem, for example, with the internet is very different than a systems problem with a piece of physical machinery, but it's all related. So I guess I should have started here, but how did you come to this? Like, how did you get involved in this whole world?
Well, I started out, first of all, my father was an engineer, and he taught me a love of understanding how things work. But also, he was very interested in how to develop the clever, simple solution to a complex problem. So he would show me, look at how they did that. This company would develop some new way of doing things. It was cheaper, better, faster, whatever. So I became an engineer, and I loved airplanes and got into that. It didn't quite work out for me because it was a bad time for aerospace. There's been it's an up and down industry. So I ended up working for another company for a while, and then went back to school and decided that the one area of engineering that isn't going to go up and down is computers. And I think I've made a good choice because computers always grow. I mean, we need more and more of them all the time. But I got a computer and systems engineering degree, which is very focused on the digital electronics and the hardware and so forth, but there's still a systems flavor to it because circuits are very complex systems to begin with. And so I've always studied systems, but again, in my case, I was studying them in a very narrow context. And then it's only once I worked out in the education field and worked with industry and just got more experienced in it, I began to realize that systems engineering is something that everybody uses and is central to all engineering, not just what I was doing. And it's of course I became the systems engineering program chair when I came here, and it's the first job I've had where that is my focus, but I've been using it for a long time. It's a part of every engineer's mindset.
So you haven't been an instructor or professor your whole career. You worked in industry?
I started out in industry. I went back to school, got a PhD in computer and systems engineering, and then became a professor. So I have been quite a few years now. I've been an educator, but I didn't start out that way. I worked for Westinghouse Electric, a great company that unfortunately no longer exists. But it was a victim of the downturn in power systems that we went through for a long time.
Right. Well, could you tell us about maybe one of the most interesting projects you've worked on that's systems engineering related? As I've learned more about it, it's really fascinating. It's everywhere. But any examples you'd like to share about things that you've seen?
Well, early in my career in industry, when I worked for Westinghouse, I was put into a department that was trying to sell hydroelectric generator systems around the world. So I had the great fortune of being in charge of putting together bids, multi-million-dollar bids. I was sort of the guy in charge in my 20s for international bids on electric power plants. And the Westinghouse only made the generator part. We had to get together with a turbine manufacturer, a water turbine, and put together these joint bids. So we had to do joint ventures and other things. It was very complex and very interesting, and it was certainly a systems application, and we did it outside the United States. I even helped negotiate. In fact, I was left in charge one day because my boss got fed up and walked out and said, "You take care of it." So I was left in Brazil in the offices of a Brazilian company to negotiate a joint venture agreement where they were going to manufacture the stuff for us. So that was one of the examples of interesting systems engineering work I've done in my career. And it's been very interesting to me.
Right. Could you talk a little bit about the kind of students we get in these programs? What are their interests? What are their backgrounds? Do you see patterns in that, the kinds of students that we're getting here at UMUC?
Well, the one pattern I've seen, which has been very pleasing to me personally, is the high quality of our students. Our graduate students are really dedicated, sharp individuals. As to where they come from a wide variety of different backgrounds, but every one of them will tell me that they are there because they want to focus in on systems engineering, which is sort of an obvious thing to say if they're getting a degree in it, but they tell me in more detail why, and I understand that they're in some kind of technology-related work. They may not have a background, an academic background in technology, but they've taken a job where they're doing technology work, and they're looking at the next level up, that leadership position where they might be able to be in charge of some other people doing technical work, and they want to be able to handle it and make themselves skilled for it, and the thing to do is to get a degree in systems engineering. It's a perfect graduate degree for somebody that's already in a technical field, in some kind of capacity where they have to have a technical understanding, not necessarily a deep understanding, and they want to run the show.
Right. Well, listen, I want to thank you for coming on and talking about it. It's a fascinating field. It's one that I didn't know much about, and as you learn about it, it really, you just see it all around. But we're very proud of your work here, and again, I want to thank you for coming on Thursday Thoughts and sharing this with us.
Thank you for having me. Appreciate it.
Thanks for watching Thursday Thoughts with Dr. Alan Drimmer. This has been a production of University of Maryland University College.